So the example we've just seen is quite difficult. It's quite hard to wrap your head around what it's talking about. The main thing is we are trying to bound, if you want, or guarantee that some expression is not too far away from 0. So remember, this statement here is the statement that the expression x cubed minus 4x plus 1, that number is distance less than k from 0. So we're trying to guarantee that this holds if I'm restricting x to be pretty close to 0, right, to be within distance 3 of 0. So we're going to go through exactly the same logic, right, as we've just done, carefully thinking what has to happen. So the essential plan is to use the triangle inequality. So let's start off by thinking about this. X cubed minus 4x plus 1. So we know for sure this is less than or equal to the absolute value of the sums of each of these pieces. So this is the triangle inequality. All right. So that's the triangle inequality. Now, each piece of this is equal to what? Well, by my nice properties of multiplication, this is absolute value of x to the 3 plus 4 times the absolute value of x just plus 1. Now, notice here everything's positive, right? I'm just adding stuff up. So this is going to make my life easy, because if I have kind of a maximum value for the absolute value of x, that will give me a maximal value for this, because all I'm doing is adding things together. There are no takeaways anymore. So what do we know? If the absolute value of x was less than 3, this would guarantee that this expression has got to be less than, what is it, 3 to the power 3, that's the biggest that piece could be, plus 4 times 3 plus 1. So what's this equal to? 3 to the power 3 is 27. So 27, then plus 12, then plus 1. So what's that equal to? It's equal to 40, isn't it? I hope. Yes, equal to 40. So let's just have a moment to think about this. We know that if this is true, then this is true. Okay, so I'm less than 40. So the conclusion is that if this is true, then my original expression that guy by the triangle inequality is less than or equal to this guy. That's the triangle inequality. But now this is strictly less than 40. And putting all this together, well, now I've got my transitive property, if you want. If A is less than or equal to B and B is less than C, A has to be less than C. So this tells me this must hold. Kind of a weird example. I'd imagine you're thinking, why on earth would anyone do this? Well, it does turn up in calculus. So, what have we got? Well, now we could choose k to be equal to 40. So choose k as 40. We could choose other k's. There's probably a smaller k that works. It's just we've chosen kind of a brute force one that will definitely work because of the triangle inequality. So it's a pretty tricky example. I really advise you to take your time with this one and think through every single step carefully. Think about why we're doing it and ultimately what the conclusion is, right? The fact is this guarantees this piece, but then the triangle inequality guarantees this piece, right? And then using them both together gives us exactly what we want. So it's a tricky example, but it's an important one.